All right, here we go, continuing with our waterfall approach to software development. Step 4 in the waterfall, the software requirements specification. The first part of this might seem a little strange, but the reality is we need to have elicitation of the requirements. We don't have all the requirements from one interview with a client. And certainly that's one of the things that we gloss over here in 342. We start you off with an interview and you start fleshing things out, and we get things moving really quickly, and we work in a real iterative fashion. But again, if you're going to do big requirements up front, this whole plan and document approach, you need to be sure that you really know all the details up front. So you actually are going to spend a lot more time on figuring out the requirements, and you're going to do that with a lot more interviews. You're going to talk to lots of people. You're going to take lots of notes. You're going to come out with all sorts of additional requirements. For an existing company, you're absolutely, or just a client that has workflows that you need to implement or modify, you're going to go and observe users using the existing software, or you're going to be automating their job, and so you need to find out how they do their current job. This, you're going to spend a lot of time digging in and understanding what are all the requirements in the problem. Again, everything, the foundation rests upon it. So yeah, you spend a lot of time with that. Then you're going to move on, and based upon that work, you're going to spend some time writing use cases. And you might very well, as part of overall your elicitation, you might use an approach called Contextual Inquiry. I think that's right. And I think in MSci 343, the Human-Computer Interaction course, you'll learn more about contextual inquiry. And it's really, this idea is, though you were going to study people, and from them, we're going to note how someone uses the software. And we're going to write a full explanation of how they use the software to complete tasks. You know, they're going to do this, and then they're going to do this, they're going to do this. You could think of this as, you know, you're going to get very detailed, full workflows or things that they can achieve while using the software. And they can range, you can talk about creating different personas. Oh, we've got, let's say you're doing tax software, it's tax time. And yeah, you're going to have a self-employed person, you're going to have a small business owner, you're going to have someone who everything is just taken care of with a couple of forms versus someone who's been busy investing in the stock market and has to deal with all sorts of things. Those could be all sorts of different personas and use cases, and you would write all this stuff up to be able to capture it all, to explain how the software is being used. Again, this is all about the behavior of the software. And this is not how it is implemented. We're going to save the implementation details for the design specification. So if you wanted an example that Stellman and Green use is talking about the search and replace text function in let's say a word processor. And so you're going to, you write this up as a user will be able to search for a word, and everywhere where that word occurs in the document, they will be able to replace it with another piece of text. But we don't say what the screens are going to look like. We don't talk about the buttons they're going to press, which menu they have to access first to get that done, what the prompts are. Do they really want to replace this? and so forth. But we would include things like they should be able to select whether to pay attention to the case of the word or ignore the case of the word. Should they pay attention to white space, not white space? What are the options? You could talk about all that stuff. That's the behavior, but you're not going to say what it looks like, and you're not going to talk anything about how it works on the back end. You're not going to say anything about the algorithm to allow efficient searching through the text to find all those things. Okay? So it's just the behavior. Then, after you've done that sort of work, you break that down. So that's sort of the high level flow and so forth, and gives you a big broad view of the work. Then you move on in your specification to deal with your functional requirements. All right. Again, you're going to derive these from the use cases. And this is basically going to be the features of the software. And these are very detailed. All of the possible inputs and outputs and so forth and so on. Everything you could envision. What are all the error conditions, the messages, and so forth and so on show up. You also put into the document, and you break them out as a separate group, the non-functional requirements. And non-functional, in other words, this is about usually observable behavior. I can press this button, I can click this, I can highlight this, I can do these things. It's observable functional behavior. Non-functional requirements are, you can talk about them dealing with things like reliability, performance. Now, you might be able to observe performance, but it's something you're just going to measure. It's not like I push this lever. It's not like how much force I'm going to push against the lever either. It's how fast and all sorts of other things, etc. You should know that there's a difference between functional and non-functional requirements. You should know that this is usually the way we think about it as observable behavior, and these are other things. And you'd be like reliability, like how long will the software stay up, without needing any maintenance, or how will it handle power outages, and so forth and so on. All sorts of stuff like that. Integrity of data, what's being done to manage that. There's all sorts of things there. And the reason to break them out separately is that sometimes we can forget to note what the non-functional requirements are, but we will have collected them from the client. And so we need to spell them out as well, because you could build something and fail to meet these non-functional requirements, and thus it will fail the user acceptance criteria. So we have to keep track of them. Now at this stage, it's good to remind ourselves about these parts now that we've made it this far. Again, remember we break things up so that the scope are the needs of the client, what's going to be built to deal with those. The requirements are all about the behavior of our system, of our software, and then we haven't gotten into it yet, but when we get to it, the design will show how the behavior is implemented. And I find that it's real important to keep track that this is really broken out in this fashion. I would say that in what we've been doing with Scrum is we blur all of this together. All right. We can compress it down to, we've got this story, and in it are all the things that the client needs how it should look, what's it going to take for the client to accept it, what's our design, how are we going to satisfy the client, what will the client be able to do with it. It's all just mixed together. The idea here was a separation of work, largely based and to be able to have different people do different things. So you're going to have developers do the following. This might be more of a analyst, program manager type role. This might be started off, it could be by the analyst, the program manager, but it could also, this could be a bit more starting from spec'd out by more of a business person. This is a big problem and these are the needs. Oh, let's go get someone trained in getting requirements and writing specifications to do this. But oh, we need the people who are actually going to build the software to do this stuff. Right now, we're kind of doing it all, mixed all together. But this historically is, again, one of the ways that we improve overall efficiency often of teams. When we talk about the Kanban approach to agile software development, you'll see that this comes out again. And that we use that, Kanban uses it as a way to speed up the processing of the teams and to speed up not to speed, but to allow us to scale our teams to be larger. And that's, it's fascinating when we get there. We're going to see all these ideas sort of intermixed and reused in different ways across the different methodologies. All right, again, while we're here, I'm going to mention that we have an ongoing thing. And I already talked about this in a fair bit, but again, you've got to have your change control, okay? And the real thing is that you're writing all these specifications. At this stage, once you've got a software requirement specification, you had better have change control in place, that no changes are allowed to the project without approval. Okay, so if you're looking to when to implement change control in a waterfall approach, at least by this stage, you gotta lock it in. Because once that requirement specification is written, everything else, many more resources are going to be deployed on the project, a lot more work, things are going to get real expensive, changes are going to be really bad. You're also likely to see in a traditional consulting approach that at this stage, you might very well, you might break a project up into parts. And so the first part, oh, we agree to work further and we'll pay you to write the software requirement specification. And then you spend all this time to write the software requirement specification and they pay you for it. And then based upon that, which they sign off on, then you begin work on the rest of the project. And you would have in place the notion that the client has signed off, these are the requirements, and we promise to build it for this cost. By the way, so you better have written a really good specification and be really good at estimating everything. Otherwise, you are going to get stoked as you do tons of work that you didn't ask for enough money for. There's a lot of incentive to get it right. Anyways, at this stage, you got your change control and everything. Then you deliver the software requirements specification, the SRS, to the dev team. You throw that document to them and say, now implement this thing. Well, you don't say implement it. Now you say design it. They're going to work on their design specification, which we're going to talk about next.